Welcome back, listeners, to another episode of Operating Systems Crashcast. I'm your host, Victor, and today we're continuing our journey through Season 1, Chapter 1, Introduction. We've reached Section 1.6, where we'll be diving into the fascinating world of process management.
That's right, Victor. And I'm Sheila, your co-host. We've covered quite a bit already in this chapter, from what operating systems do to their structure and operations. Now we're going to explore how operating systems manage processes, which is a fundamental concept in OS design.
Absolutely, Sheila. But before we jump in, let's start with our traditional quiz question. Listeners, here's something to ponder. How many basic states can a process be in during its life cycle? Keep that in mind, and we'll reveal the answer at the end of the episode.
Great question, Victor. Now, let's lay down some fundamentals. At its core, a process is simply a program in execution. It's the active entity that brings a static program to life, using the computer's resources to perform its tasks.
That's a great starting point, Sheila. To expand on that, process management is one of the most crucial responsibilities of an operating system. It involves creating and deleting processes, scheduling them for execution, and managing their interactions.
Exactly, Victor. You know, I like to think of process management as running a busy restaurant kitchen. The operating system is like the head chef coordinating all the activities. The processes are like individual dishes being prepared, each needing specific ingredients, resources, and cooking time, CPU time.
That's a fantastic analogy, Sheila. Let's break it down further. In our kitchen analogy, creating a process is like starting to prepare a new dish. The operating system allocates the necessary resources, such as memory, our ingredients, and initializes the process control block, which we can think of as the recipe card for each dish.
Right. And just like in a kitchen where dishes are in different stages of preparation, processes in an operating system can be in various states. The basic states include 1. New. The process is being created. 2. Ready. The process is waiting to be assigned to a processor. 3. Running. Instructions are being executed. 4. Waiting. The process is waiting for some event to occur. 5. Terminated. The process has finished execution.
Excellent explanation, Sheila. The operating system manages these state transitions, much like our head chef deciding which dish to work on next, or which one needs to wait for the oven to preheat.
Absolutely, Victor. And just as a chef needs to keep track of each dish's progress, the operating system maintains information about each process in a data structure called the Process Control Block, or PCB. This contains all the information needed to manage the process, such as its current state, CPU registers, memory limits, list of open files, and more.
The PCB is crucial for multitasking operating systems. When the OS switches from one process to another, it saves the current process's state to its PCB and loads the state of the new process from its PCB. This is called context switching.
That's right, Victor. And in our modern world, we see process management in action all the time. Take smartphones, for example. When you switch between apps, you're essentially watching the operating system perform process management in real time, switching contexts and managing resources for different processes.
Great point, Sheila. Process management also involves scheduling, which determines which process runs when. This is critical for ensuring fair access to the CPU and maintaining system responsiveness. It's like our head chef, deciding which dish to work on next to ensure all orders are completed efficiently.
Exactly. And it's worth noting that modern operating systems often use threads, which are like lightweight processes. They allow for even more efficient multitasking, but that's a topic for another episode.
Indeed it is, Sheila. Now, let's recap the key points we've covered about process management. 1. A process is a program in execution. 2. The operating system is responsible for creating, scheduling, and terminating processes. 3. Processes can be in different states: new, ready, running, waiting, or terminated. 4. The process control block, PCB, stores all the information needed to manage a process. 5. Context switching allows the OS to multitask between different processes. 6. Process scheduling ensures fair and efficient use of system resources.
Excellent summary, Victor. Now it's time to answer our quiz question. Victor, do you remember how many basic states a process can be in during its life cycle?
Great question, Sheila. The answer is 5 basic states: new, ready, running, waiting, and terminated. These states represent the life cycle of a process from creation to completion.
That's correct, Victor. And with that, we've come to the end of today's episode on process management. We hope our listeners found this information helpful in understanding how operating systems juggle multiple tasks efficiently.
Absolutely, Sheila. Thanks to all our listeners for tuning in. If you enjoyed this episode, don't forget to subscribe to Operating Systems Crashcast. Join us next time as we continue our exploration of operating system concepts. Until then, keep your processes running smoothly.